Hello everybody and welcome back. Root Beer here with question number 23 on the Fermat paper from the year 2000. Alright, so question 23. It's got a nice little diagram over here on the right involving a rectangle. So, a circle is tangent to three sides of a rectangle, having side lengths 2 and 4 as shown. A diagonal of the rectangle intersects the circle at points A and B. The length of AB is, and then we have some options here. So, first of all, let's draw ourselves a little picture and see if we can better understand this circle. I mean, it's tangent to two sides, so maybe we can figure out its diameter and therefore its radius. Probably should have drawn the circle first and then drawn the rectangle around it, but oh well. Alright. So then we connect up to a diagonal and we have A and we have B, and we know this is length 4 and this is length 2. We'll just make sure that this is actually tangent to the circle. Alright. So it's pretty quick to see that if we plop in the center here, O, and drop radii down to all of our points of tangency, we can see that our radius, pretty quickly, this diameter has got to be 2, because points from the radius to the point of tangency always hit at perpendicular angles. So this length here, this diameter has got to be 2, and so each of these radii is 1. So that's pretty useful to know. In fact, the diameter is 2. And this has me a little suspicious. So we have these A and B, and they're what's known as a chord. You take 2 points on the circle and you connect them up. But chords are never, ever, ever bigger than the diameter. Sometimes they can be as big as the diameter. The diameter itself is a chord, but no chord, like A and B, can be bigger than the diameter. But wait a minute. Some of the potential answers for the length of AB, I mean, root 5? Root 5 is 2.23 or something. Let's see. So if AB had length root 5, it would be bigger than the diameter. So A is out. Root 5 minus 1/5, 0.2. That's also going to be bigger than 2. So C is out. And I'm pretty sure D is out as well. Oh yeah, well it's got to be. 1/5 is bigger than 1/6. So definitely. So A, C, and D are already out just by realizing that chords can't be longer than the diameter. So that's pretty interesting. I really like that. We're no closer to actually getting the final answer. But just a little bit of thought has allowed us to rule out 3 of the possibilities. So if I were stuck, if it were the final moments, I would take a guess, because now I have a 1 out of 2 chance of getting the right answer. Whereas before I would get a 1 out of 5 chance. And on any of these questions, if you don't know anything about it, if you have a 1 out of 5 chance, it is best to leave the question blank and get the 2 bonus marks for admitting you don't know. But if you have a 1 in 2 chance, I say take it. Alright, so I think that's really neat. Just a little bit of thought about the chord, and automatically A, C, and D are out. Now, how are we actually going to solve this? A and B. Well, this triangle here has side lengths 4 and 2. So this angle, neither of these angles are particularly nice. I'm pretty sure B is going to be at the point, it's going to be up 1 and over 2. So that might be something. But I don't really know anything about the point A. So I think what I'm going to do is I'm actually going to use algebraic geometry. And I'm just going to put everything on a grid. So I'm going to redraw my picture. Oops, I'm still in purple. So I'm going to say the corner of the box is 0, 0. And we go up a height of 2, so we're at 0, 2. And then we are at 4, 2, and 4, 0. And now the circle, which again I should have drawn first. Oh well. Circle has center, well, it's over 1 and up 1. So the center of the circle is going to be 1, 1. And the diagonal is going to be the line through 0. So it's going to have a y-intercept of 0. And it's going to intersect 4, 2. So now that we've given the circle a center, we know the circle has equation. Well, it's going to be, once we have the center, we take out the x-coordinate of the center, and we subtract it off from x. The y-coordinate of the center, and then when we add them up, it equals the radius squared, which in this case is just 1. So now we have an equation for our circle. And we're about to get an equation for the line, the diagonal. I could probably detail a little more how I'm getting this equation, but I know I have y-intercept of 0, and I know if I want 4, 2, I'm going to have 4 by 2. I mean, it's the Fermat paper. Lines are like, what, grade 9 or something? So this isn't a particularly hard line to get, so I'm not really going to detail how I did that. So now we have y in terms of x. And at the point of intersection, so A, B are the points of intersection of the circle and the line. So that means I can plug in the formula for the line into the circle. So x minus 1 squared plus 1/2 x minus 1 squared should be equal to 1. And now I can expand this, collect like terms, and hopefully I'll get something I can use to solve for these x values. And once I know the points A, B, it's going to be very easy to find the distance between them, so that line segment. So x squared minus 2x plus 1 plus 1/4 x squared minus x plus 1 equals 1. Is this one right? Negative 2 times... Yeah, okay. Alright, so that is correct. So if we collect like terms, we have 5/4 x squared minus 3x. We have plus 2, and then we have 2 ones, and then we have another one over here. So this one and this one will cancel out. We'll just have plus 1 equals 0. So now we have a nice, healthy quadratic formula. And if we solve for x's, then we can immediately solve for y's using our diagonal equation, and we'll know the points A and B. Okay. So there's a couple ways I could solve this. Quadratic formula is an obvious one. But I think I said before, looking at the original picture, I think B is exactly 1 unit high up and 2 units high over. I think it's right at the edge there. So I'm actually going to take a little bit of a gamble, because I'm so confident, and I'm going to see x equals 2. Is that a solution here? Well, 5/4 2 squared minus 3 times 2 plus 1. Those are going to cancel out. We're going to be left with 5 minus 6 plus 1. Wouldn't you know it equals 0? Yay. Okay, so now I can just take out a factor of 2 or something like that. And is there an easy way to do that? So x minus 2 is what I want to have come out. So I will keep the 5 quarters x. So 5 quarters x times x, that's definitely going to give me x squared. I need minus 2 times another minus a half to get that 1. And then I should have negative 2 times 5 fourths is negative 5 halves. X plus negative a half x, that's going to be minus 3x. So this is the factored form of the formula. So x equals 2 is a root, and x equals 4/5, 1/2, 4 out of 10, 2/5 is the other one. Okay. And when we plug in 2/5 over here, we'll get 4s will cancel out, 5 and another 5, so it'll be 1/5 minus 6/5 plus 5/5. So yeah, these are our two values. And y is equal to 1/2 of x. So b is going to have coordinates x is 2, and then y is a half of x, so 1. And a will have coordinates 2/5 and 1/5. Okay, so that's very quick, very simple, and now we have a and b. And we can go back and we can label them as such if we so desire. 2, 1, and then 2/5, 1/5. And we could double check that they're on this circle, and I'd say it's pretty clear that they're on the line. But there we have a and b. Now we're asked for the length between a and b. And I'd actually be very interested to see, can you do this without putting it on the Cartesian plane? Is there a way to do it without? I can't see one, but I'm always willing to be impressed. So leave a comment if you have another way to do this that doesn't involve adding coordinates everywhere. Now, if we want the length AB, we use our little distance function. And so we take the difference in the x coordinates and square it. And we take the difference in the y coordinates, keeping the order the same, although it doesn't really matter, and square it. So 2 minus 2/5, that's going to be what, 8/5, all squared. And then 1 minus 5th, that's going to be 5/5, sorry, 4/5, all squared. And then we'll have 64 over 25 plus 16 over 25. So that becomes 80 over 25. And 80, I can take so when I do this, I can change it to square root 80 over square root 25. So that's going to be square root 80 over 5. And 80 happens to have a factor of 16 in it. So I can pull out square root of 16, which is 4. 4 root 5 over 5 is our final answer. And wouldn't you know it, that is one of the two answers that we had remaining. Remember, we eliminated A, C, and D just because they're simply too large. But 4 root 5 over 5, our answer B. I think that was a very nice question. And as I said, please leave a comment if you have a way to do this without using coordinates. But yeah, I think that was very nice. And I really like that we could eliminate 3 of them right off the bat if we just stopped and think about lengths for a moment. So, good question. Hopefully 24 is just as good, but we'll see that in the next video. And thank you guys so much for watching, and I'll see you next time.